Ever wondered why, if you throw something in the air, it falls back? And why things fall down if you drop them? There is a force behind this called gravity. What is gravity? Simply said, it's the attraction of things with mass or energy to each other. Or a more formal definition is that gravity is the force of two or more masses or energy attracting each other. Gravity is one of the four fundamental forces of physics. It is by far the weakest of them all. The strongest one is the strong nuclear force, which is astronomically more stronger than gravity. The big difference is that this force holds matter together at the tiniest atomic level, while gravity is the dominant one at the macroscopic level and is responsible for the formation of planets, stars, and other celestial bodies. So why is gravity so special? Because everything with a mass has gravity. Although almost neglectable, even the smallest of atoms. It exists in all the masses in the universe. It is so omnipresent that it will even attract and bend light that passes a planet. There is a great chance that if you observe a star in the sky which lies behind a large mass, such as a white dwarf or a very large planet, the actual location of that star in the sky is somewhere else. Gravity does that. If you drop something, it falls to the floor. But in fact, gravity is pulling it to the floor. As said, gravity is a relatively weak force. We humans can easily defeat it. Hold your arm up and gravity won't be able to pull you down. And since our body is held together by one of the four more stronger forces, it won't shatter in pieces while gravity is trying to pull us flat to the earth. If we would have wings just like birds, we would be able to lift off from Earth and gravity would not be able to pull us down. But let's not underestimate gravity. Gravity is pulling all the time, always, never ending. The larger and denser a planet is, the stronger the gravitational pull is. The formation of a stellar black hole is in essence the consequence of gravity. In a sun-like star, weighing at least 2 to 3 times more than our own sun, gravity also pulls constantly on the outside, trying to bring it to the inside of the star. However, the burning part wants to go away from it, keeping the size of the star in balance. But whenever the star runs out of fuel, gravity will get the upper hand and pulls the planet in on itself, making the gravity so strong nothing can escape from the center of the black hole. Not even light. Even time stands still. Gravity also plays an important part in our solar system. The planets in our solar system orbit around the sun. Around these planets, moons circle. Due to gravity, our moon circles around our planet. Earth is pulling on the moon, but the moon's gravity is also pulling on Earth. The strength of gravity between two planets is not only determined by the mass of the planets, but also by the distance they have between each other. The tides are a consequence of this. The moon pulls on the side of the Earth where it passes by, and as a consequence, therefore not on the other side of the Earth, causing higher tides on the side it is pulling. Could we make use of gravity for our own purposes? Ever wondered why a geosatellite keeps hanging in the sky? A geosatellite is mainly used for commercial purposes, such as television broadcasts and internet connectivity in areas where there is no cable. Its position must therefore be fixed to a location on Earth. Since the Earth is spinning, it must meet the speed of the Earth in order to achieve this. This can be done above the equator and is called the geosynchronous equatorial orbit. It is accomplished by launching the satellite to an altitude of 35,786 kilometers above the equator and give it a push to reach a speed of 3.07 kilometers a second. Now, where does gravity come in? After this initial push, the satellite will use no fuel to fly. It will receive the one-time push at a certain angle away from Earth. The satellite then has the tendency to move away from Earth, but gravity will pull it back to Earth, and so forth. Our bodies are used to the gravity on Earth. Our muscle, bone, and vascular systems are designed for and adapted to the gravity on Earth. Since the gravity on the moon is much smaller, we would be able to jump much higher than on Earth. However, if we would live longer away from our Earth's gravity in space, it would be devastating for our body. In such event, we would need to make artificial gravity. This would usually be done by creating a centrifugal force. Is there a way to defeat gravity? Gravity has no opposite force, such as an explosion has implosion as a negative, so there is actually no way we can resist it. But we can escape from gravity. If you would throw a ball with such a speed in the air that it would exceed the escape velocity speed, gravity would not be able to pull it back. On this principle, the launching of rockets and spacecrafts is based. We should not worry about defying gravity, but embrace it and make use of it if we can. After all, it is what keeps our universe in a predictable state and helps us keep our feet on the ground. Thank you for watching. We have given you a small look into this subject. We might have missed something. We might have gotten something wrong. Let us know what your thoughts are. We hope you stay around for another episode. Only if you like this video. Please subscribe to see more episodes.